So in this section, we're going to talk about finding the absolute max and min of a function on a closed interval. Okay, so if I have a continuous function on a closed interval, here is what you do. So first, just verify that the function is continuous. And just to make sure that you know what's going on there, right? That you're actually doing the part that this process applies to. Okay. After that, step one: find the critical points. Then evaluate the function at the critical points and the endpoints. And endpoints. Step 3 is decide which is the max. So largest is max. Smallest is min. And I'm using the word smallest here. -2 is smaller than -1. Okay, so in the number line sense. Okay, this is pretty straightforward. Let's go ahead and do some examples. So step 1, or I should say example 124 here. G of t is equal to this third degree polynomial on the closed interval -4 to 2. And so polynomials are continuous. Step 0 is done. Step 1, find the critical points. So g prime of t is 6t squared plus 6t minus 12. And let's set that equal to 0 and go ahead and factor out the 6. And that gives me t squared plus t minus 2, which is t plus 2, t minus 1, which means that t is -2 and +1. Those are my critical points. And then what we'll do is we'll evaluate g of t at our critical points and our endpoints. So critical point, endpoint -4, critical point -2, critical point 1, endpoint 2. And I'll just plug all of those in. Now, if you want to kind of cheat, you certainly can. I want to plug these into the original function, not the derivative, into the original, right? So 2t to the third power. To the, 2t to the third power, there we go, plus 3t squared minus 12t plus 4, and of course I'm using x here. And the table, we want the table to be on ask, just in case it's not. So let's go back to our table. Don't want any of those. I want -4 and -2 and 1 and 2. Okay. So I get -28, +24, -3, and 8. So what do we say here? So the absolute max is 24. And it occurs at t is equal to -2. The absolute min is -28. And it occurs at t equals -4. Okay, so again, this is the absolute max, this is the absolute min. Here are where those two things happen, all right? And if we graph this function, we can kind of get an idea about what happened here. So the function, we're going on -4, right? So it went up like this, and then down, and then up again. But we cut it off before it made it up further than this. On the left-hand side, we went lower than this relative min here. So I had a relative min there. This absolute max is a relative max. And there we go. So that's the visual for what happened in this problem. Let's try another one. So determine the absolute max and min of x squared minus 4 cubed on the interval -2 to 3. Now, we could certainly, expand that out, but let's definitely not do that. It is continuous, so let's find the critical points. F prime of x is going to be 3x squared minus 4 squared times 2x. And this is a lovely problem in that it is already factored, right? So when I set it equal to 0, it's 6x times, this factors as x minus 2, x plus 2, and each of those will be squared because they inherit the square from that thing. And so my critical points are x equals 0, 2, and -2. All three of these are in this interval. One of them actually happens to be an endpoint, which I'm perfectly fine with because it saves me something to plug in. And so I'm going to plug in all of those x's. What are they? They are -2, then 0, then 2, then 3. So 4 things to plug in here. And let's just do them all by hand. So when I plug in -2, I get -2 squared is 4. 4 minus 4 is 0. That gives me 0 cubed. The same thing will happen for 2. 2 gives me 0 cubed. I need a calculator for that. When I plug in 0, I get -4 cubed. That's -64. And when I plug in 3, I get 3 squared is 9. 9 minus 4 is 5. 5 cubed is 125. So we didn't need a calculator on that one. So what's the absolute max? Absolute max is 125. Absolute min is -64. All right. One more here. Determine the absolute max and min of x minus 2 arctan x on the interval 0 to 4. Okay. Well, we have to make sure we remember what the derivative of arctan is, so we can go look that up if we don't know. Is it continuous on 0 to 4? And the answer is, yeah, arctan is continuous for everything. So we're good to go there. And so is x. So g prime is going to be 1 minus 2 over 1 plus x squared. So the derivative of arctan is 1 over 1 plus x squared. And it might be good to combine some like terms here. So I get 1 plus x squared minus 2 over 1 plus x squared. And that is kind of weird, flipped around. The top I get x squared minus 1. The bottom I get x squared plus 1. The bottom is always positive, and so the bottom is never 0. That's good. This thing doesn't have any domain issues. And so when I set g prime equal to 0, all I have to do is the numerator, right? So just so when I set g prime equal to 0, I get x squared minus 1 equals 0, which is x minus 1, x plus 1. And that gives me x equals 1 and -1. So these are my critical points of this function. However, they aren't both in the interval that I'm concerned about. So I don't need to worry about the point that falls outside of the interval I'm looking at. And so all I have to do is plug in 0, 1, and 4 into my function. And there we go. Why don't we do a couple of these by hand and we'll let the calculator help us on the other one. So what about this? So let's find g of 0. So I get 0 minus 2 arctan 0. Okay, so remember that arctan, tangent of what angle gives me 0? And the answer is 0. So that one is 0. And so I get 0 minus 2 times 0, that's just 0. What is g of 1? Okay, so that's 1 minus 2 arctan of 1. All right, what angle has a tangent of 1, and so that's going to be 1 minus 2 times pi over 4. So I get 1 minus pi over 2. We'll get an approximation for that. 1 minus pi over 2. And then g of 4, I'm probably going to need some help with. 0 minus 2 arc tan of 4. What angle has a tangent of 4? I have no idea. So we'll go ahead and get some help here. 1 minus pi over 2. I'll put a decimal in there to give me an approximation. So that's negative 0.570. Oops, not sure what happened there with my 5708. And then the other one, I'll just make sure that I'm in the right mode here. So I am in, I need radians. Radians, good to go. So it should be a 4, not a 0, 4. 4 minus 2 times arctan of 4, 1.348. We'll call it. Okay, so what I know is that the absolute min is 0, and absolute max is 4 minus 2 arctan of 4, which is about 1.348. Okay, so just a quick recap of what we have done in this section. We talked about what relative maxes and mins are, for starters. So first, what are relative max, relative mins, and absolute max, absolute mins? We talked about how there was some discrepancy between what I think and what the book says. We talked about the extreme value theorem, which says on a closed interval, we are guaranteed to attain our absolute max and min inside that interval. We defined critical points, and then we said local maxes and mins happen at critical points. Then we spent and we did a bunch of examples of finding critical numbers for functions, and then we used those critical numbers to find absolute maxes and mins. Later on, we will determine how to use critical numbers to find relative maxes and mins. So that'll be in a later section, okay? The next thing we're gonna do is going to be talking about the mean value theorem, and I'll see you then.